Moving on to an equity valuation example. This is an evaluation example of Apple, and what we're doing here is we're looking at earnings. We're looking at a discounted earnings model, essentially, and then there's a couple parts to this on top of that, where we look at earnings and we, for example, we start and we say that's a growth of, say, 18%, and that could be changed around. But that's the prediction right now, for example. What's the discount factor? That's based on the risk rate, so we can have a certain risk rate. Then we have the discounted earnings, right? So as we go through that for year 1 through 5, this is 5 years of that through 2023, and then we take the present value of that. So just as the other example, we take the present value, that is what the value of the earnings in the next 5 years. Now the terminal value is something where we say, hey, we're not going to keep doing this for like the next 100 years, so we're just going to look at earnings in year 6, and we're going to say that's going to be a growing perpetuity, right? A growing perpetuity. And we're basically saying it's kind of like, say you won the lottery and you're going to just keep getting payments of 160 million, but it's growing at 18, it's growing at a certain rate, right? So let's see what we ended up using. So we ended up using the risk rate of C3, right? So this is E4 minus C3. So we're saying that essentially the growth rate is 2%. So the risk rate we're saying is 13%, and the ultimate growth rate is 2%. Okay, so that is the value, and this is the formula here. This is a little bit tricky, but the formula says here that a value of a growing perpetuity is actually the cash flow, which we have. Okay, and we have the cash flow, and then the formula is R minus G, where R is the risk rate and G is the growth. So in our case, the R is going to be the risk rate, and the growth, and the growth is usually the GDP rate, and then that growing perpetuity, we have the value of it. This is what it's worth, 1.4 billion. So we could say, oh wow, that's a lot of value for this company. That is actually what it is worth, but we're not going to get it till 2024. So now we have to go back and say, okay, what would that be worth now? And we have to divide by the present value, which is the after it's discounted 672. So this whole thing, and then what do we end up saying? We end up saying that this is the value of the company. It's the present value of the earnings and the present value of this perpetuity, and together they're actually worth $1 billion, right? And the other part of this is we can go online and double check what is it trading at, and then look at the difference. So you know, this is how you can reconcile back to is this even have anything to do with reality, right? So we did all this work, and then you could actually reconcile and see what it's trading for, and then of course, what is the difference? The difference is obviously related to one of the assumptions being different, whether we have, you know, actually the GDP rate is not going to grow at 2%, it's going to grow at 2.5%. So that's why if you play around with this, I've put in here several different models that, you can kind of actually move around until it reconciles. And then that is the idea of actually you can reverse back into the correct number, which I think is pretty interesting, and also gives us an applied way of valuing stocks.